Good afternoon, welcome again. Sorry we got a little delayed, I think by 1 minute. There was some problem in the network, so we got delayed. So welcome again, and first of all I wish you in advance happy Diwali, and I hope you are doing great, you are enjoying this festive session. And secondly, you are not attending any school, so you got a lot of time to roam in market to purchase different things. Anyways, so today again we have come up with more projects based on Arduino and sensors and their interfacing, and we'll be programming them again using visual programming. So first of all, I would like to ask one question. How was your experience in the previous session 1 and session 2? I'm looking there. So we have Pratika, we have Uday, we have Suraj Goswami, we have Chetan, and Sanket, show me the chat. We have Partyagi, we have Naman, we have Amlan, Shabd Sani. Welcome you all, welcome you all. Thanks for joining. Avikam, educational learner. Great, great, great. Okay. So we discussed in our previous session interfacing of sensors. Even we discussed about PIR sensor also, its interfacing. Now we'll start with one new project. So we'll start with gas sensor. Have you ever heard about firefighting system or smoke sensors? And many times you might have seen in movies that whenever a smoke sensor detects smoke, automatically what happens, that water sprinkler starts in hotels, in buildings, in malls, in different utilities areas, in different places, which comes in utilities, and how that particular thing works actually. So today we will be going to discuss about gas sensor and how we interface and how we can use it in our Arduino. So here we have our sensor in front of our project with gas sensor. Excuse me, I have to open one PPT also. So I'll show you with the help of diagrams also. But first of all, let us see this project. So what we have here, we have one Arduino Uno, again a controller which is interfaced with one gas sensor. This is our gas sensor fitted here. We have one piezo, or you can say one piezo speaker here, which will be used to alarm whenever there will be smoke, and will be indicating different conditions of gaseous content, gas concentration, with the help of this RGB LED with 3 different colors. So now we'll start it. Let's see the simulation first. When we start this project, what we are seeing in simulation, this is the smoke. So this is the gas which is present in an area, and you will see that when this is far from the gas sensor, or you can say when the concentration is less, automatically what will happen? What will be the reaction of this gas sensor? Nothing. That means it is not detecting enough gas to alarm. And you can see in LED also, the LED is blinking, is showing by different colors. But when I bring this gas nearer and nearer, the alarm is the piezo sensor, the piezo speaker will be sounding with different frequency and more louder. So this gaseous concentration, whenever I am bringing this gaseous concentration towards the gas sensor, the, our speaker or our piezo is alarming with different sounds. And you will see one more thing, that when this will come near to the smoke sensor, the smoke, this LED will be glowing in red color. So this is what we have programmed in this project. So this is a firefighting. This is an example of a firefighting system when we have used this smoke sensor. If you talk about the smoke sensor, what is smoke sensor? It is actually, there is a series of smoke of gas sensor which is MQ series. So it looks something like this, fitted with the module, and there are 4 connections to power it. And as you can see, this is a circuit diagram. Don't take it seriously, but what main thing is this, that it is used to detect the presence of or concentration of gases in atmosphere. So you can use it to detect methane, butane, LPG, carbon monoxide, alcohol, ethanol, smoke, hydrogen, ozone. Sorry, it's mistake. It's ozone and flammable gases, etc. So you can see it here if it is not visible to you. So MQ series sensors comes in different range, MQ2, MQ3. Based on our requirement, we use it in different applications. And then if we talk about its program, now we'll move to the program. Now we'll see the code. As you are seeing in the code, what we have done here, that we are reading the status of this gas sensor with the help of analog pin A0. So these 2 pins, 5 volt, and this ground will be used to connect this analog sensor, will be used to power this analog sensor, this gas sensor, and this pin which is connected with the orange line, this pin is connected to A0. So this will be giving an analog signal, variable signal, which will be indicating or which will be telling to the controller that this is the intensity of gas in a particular area, wherever you will be fitting this. And when we look at the code, what we are doing, we are actually measuring the analog value, and we have fixed it at a particular, value 487. If analog sensor is measuring, or if it is below or equal to 487, then what we have to do, we need to keep the speaker off, which is connected to pin number 9. So we'll turn off the speaker. Then we'll be setting pin number 6 and 3, which is connected to RGB LED to blue and green. So we'll make them we make the red LED low, that means we have to keep the LED off, and we have to keep LED 3 high. Then again we'll give a delay of 1 second. Then again we'll make the LED RGB LED high, which is connected to 5. So there are 3 pins for red, green and blue to glow the LED in 3 different colors. So if the gas content, if the value of the gas is less than or equals to 487, we'll keep red LED off, and we'll keep turning on green and blue LED on and off. But if the content which we are measuring, and if it is more than 487, using analog pin A0, then what we need to do? Then we need to turn off our green and blue LED, and we need to turn on our red LED. One more thing is there, the intensity or the luminosity of red LED will be directly dependent on the concentration of gas. So whatever be the value of analog sensor, it will be directly affect the intensity of LED. If it is more, intensity of red LED will be more. In the same way, the speaker piezoelectric piezo speaker will be sounding, which will be, which will also directly dependent on the intensity of the concentration. So whatever be the analog value will be directly glowing the LED and will sound the speaker with the intensity of the, based on the intensity of the gas. So this is our simple program which is used to alarm and indicate with the help of red LED. So the program is quite simple. Only thing is, in first case we know that if the intensity is below a particular level, in that case green and blue LED will glow one by one with an interval of 1 second. If intensity is greater than this, then we need to turn on red LED and we need to turn on the alarm, which is in the form of our piezo speaker. So this is our program. If we talk about the flow chart. So this is our flow chart. As you are seeing on screen, what we are doing here, when we start, our first condition is that is there smoke? That means, is the value of analog input is less than or equals to 487? If it is true, then what we need to do? We need to turn off red LED and we need to turn on green and blue terminal of the RGB LED. Then again we will be checking the condition. Is it greater than 487? If it is true, then we need to glow red LED and we need to turn on the speaker. So this is the flow chart. So before writing the program, our strategy should be like this. Just first we should make our flow chart. By the help of flow chart, we can easily program our system. Then this is our first program. I hope you got the idea, the concept behind this. Now, moving to our next interfacing example. Which is motor control, and many a times we forgot to ultrasonic sensor. So our next project is ultrasonic sensor, based on ultrasonic sensor. Oh, okay. How many of you have heard that there is a bird and there is a sea animal which use ultrasonic waves to detect objects or obstacle? Have you seen any bird or sea animal? As I told you in my previous session also, that whatever technology or whatever concepts we are using in our daily lives, all of the concepts were taken or discovered or still or revealed from nature only. So one of the example here I'm quoting is ultrasonic sensor. So ultrasonic wave is a wave of frequency, a range of frequency which is very high, almost greater than, I forgot the figure, 10,000 hertz. Check the frequency range of ultrasonic sensor. So ultrasonic ultrasonic wave is a high frequency wave which bat uses. Bat is one bird which use ultrasonic waves to detect an object. So a bat transmits the wave, and when the wave strikes to the object or something there in his way, in his path, it reflects back, and from the transmission and from the reflection of that wave, it detects that how far or how big that object is. In the similar fashion, dolphin use ultrasonic waves. They send the signal, they send the burst of ultrasonic waves in water, and by that they detect their object, their prey, whatever they are hunting in sea. How they detect? They send ultrasonic waves. So this sea animal and this bat, they both use ultrasonic waves to detect their objects or the size of the object. So in the similar way, we use ultrasonic sensors. So this ultrasonic waves range from 3 to 10 megahertz, which is very high. So we cannot listen, we cannot sense ultrasonic frequency. Only I think dogs can sense this high frequency. Anyways, as you are seeing here, we have this ultrasonic sensor, which is where we have 4 pins. So 2 pins are there to power it. One is ground, that means the far right pin, the fourth pin, and the first pin. The first pin is for giving 5 volt DC. So these 2 pins will be used to power this ultrasonic sensor. And as you are seeing, these 2 round shaped speakers, they will be used to generate and to transmit a wave, the waves in the atmosphere. And the range of ultrasonic sensor, this HCSR04, is 4 meter. So these 2 pins will be powering this ultrasonic sensor, and this trigger pin. This trigger pin will be used to by our Arduino board will be sending one signal to activate it, to send the ultrasonic waves. And when this ultrasonic waves, as you are seeing in this diagram, this transmitter is sending these waves, and when it will strike to the object, again it will come back to another round shaped speaker, which is receiver. So we'll be using this echo pin to detect this delay. So this ultrasonic wave will take a time from transmitter to object, then object to receiver. So from this we'll get one time, as you are seeing on screen, that there is a formula: distance equals to time into sonic speed. So sonic is the speed by which ultrasonic wave moves. So by this we'll be detecting the distance. Automatically Arduino will measure all the distance, whatever be the distance we need to measure by the help of ultrasonic sensor, and we need to divide it half. Why? Because the wave is traveling 2 and 4. So it is traveling double of the distance at what the object is there. So in this way we use ultrasonic sensors to measure distance. As I told you, we can measure it range, or it can measure up to 4 meter of the distance. Now coming to the project, what we have done here, we have used one ultrasonic sensor which is connected to 5 volt and ground, and then these 2 pins trigger pin is connected to our pin number 2, and our echo pin is connected to pin number 3. So these 2 pins, so pin number 2 is output pin of Arduino, because Arduino need to send a signal to ultrasonic. When the signal will be there, it will ask ultrasonic to send the ultrasonic waves. And when ultrasonic sensor will detect the reception of the waves, reflected wave, the wave will move and reflect back to ultrasonic sensor receiver. So whenever it will receive, again it will send the signal to pin number 3 using the echo pin, that it has detected the reflected wave. Then what we have done, how we have programmed it, we will be measuring the distance at dividing it into 10 centimeter. So when we will be having a 10 centimeter of, when we will bring an object in front of ultrasonic sensor, and if it is in the range of 10 centimeter, first LED will glow, and the same way the LEDs will keep on glowing one by one based on the the distance of the object from ultrasonic sensor. As you are seeing in the diagram, in this diagram, we have ultrasonic sensors. This is our object. When, let's say, over here, so this is a range. When the sensor is within a range of 20 less than or equals to 20 centimeter, first LED will glow. If it is more than 20 or less than 30, then second LED will glow. If it is more than 39 or less than 40, third LED will glow, and the same in a similar way. When we keep on increasing, the LED will keep on glowing one by one based on the object distance from ultrasonic sensor. So this is how we have programmed it, isn't it? So you can also say that we are actually detecting the distance of an object from the ultrasonic sensor. So whenever you need to detect, whenever you need to fit, you need to measure distance in your project, ultrasonic sensors will be the best option for you, because it can operate in any condition. You can use it in open light, where infrared sensors cannot be used in open light. So ultrasonic sensor will be the best fit for your project, for your application in any project. For let's say your mobile robot, you can fit it in front of mobile robot. Whenever you will detect an object, you can stop your mobile robot, and you can fix the range. In the same way, you can use it in detecting the water level. And there are many more applications where you can use your ultrasonic sensors wherever there is a requirement of sensing your distance. Now let's look on the code. So the first thing is that we need to measure a distance from the ultrasonic sensors. So first, what we need to do, as you are seeing in the program, we have to first configure our ultrasonic sensor. That means we need to tell that at which point or which pin you have connected your trigger pin, which is connected to pin number 2 as per our project, and pin number 3, which is connected to pin number 3 of Arduino connected to eco pin of your ultrasonic sensor. Then in what will be the unit in which you will be sensing. So you can sense it into centimeter, or you can sense it in inches also. So let's take it centimeter only. Then we'll be running the condition. What is the first condition we have put here? If the distance which is fed, which we are getting by ultrasonic sensor is less than or equals to 10, what we need to do? We need to on first LED, which is connected to pin number 4. So first LED is connected to pin number 4. You can see it here. This is connected to pin number 4. So if the distance is less than or equals to 10 centimeter, our first or pin number 4 will get actuated, or it will actuate, or it will make the LED high. Otherwise, keep the LED low. Oh, sorry, it's greater than, I'm sorry, it's not less than, greater than or equals to 10. Okay, now another condition, if it is greater than or equals to 20, then second LED will glow, which is connected to pin number 5. Then if it is greater than 30, then third LED will glow, which is connected to pin number 6, and so on. So we are measuring it up to 100, greater than or equals to 100. You can change it. It depends on your requirement. It is just an example at how you can use your ultrasonic sensor in your application. And instead of your LED, you can fit one motor also. You can change the speed of motor. That if an object is coming closer and closer and closer to the ultrasonic sensor, you can increase the speed of your motor. In that condition also, where else we can use it? And there are many more applications also, but thing is, What do you think? What else may be the application of ultrasonic sensor? Write in comment section. Where else we can use this ultrasonic sensor in our application? Muhammad Abdullah. If and else is used when we face more than one possibility, probability. Yeah. Definitely, when we used to do something and we set a condition or conditions also. If this is true, we'll do this. If this is not true, we'll do this. If those two conditions are also not favorable or not true, we'll move to some another condition. So you can set any number of conditions in your task. So daily in our daily lives we use all these conditions. We're never stuck to a single condition. Uh, there are certain conditions are there where we become adamant that no, I'll do my work with this condition only. But most of the time, whenever we used to do something, we set some certain conditions. So what? Okay, to detect bomb, Tyrannosaurus. Detect bomb. No, then it will not be. In submarine, yes. In submarine we can use it. And Sonovia Kulsum has said that if they emit sonar waves, that's what ultrasonic waves are. Sound waves. Yeah, ultrasonic is a sound wave. All the frequency are sound waves. So there is a range. There is a range of frequency which we can sense, which are audible to us. Return check the audible range of frequency for human being. I'm checking that what is the audible range of frequency for audible frequency range. So audible frequency range for human hair is 20 hertz to 20 kilohertz. So this is the frequency range which we can, which our ear can listen. Above this, we cannot listen these sound waves. So whatever frequency, whatever signals are there, which are ranging from 20 kilohertz, above 20 kilohertz, those will be not audible to us. So, is it clear? We can use this sensor in submarine, aeroplanes, and etc. to make scone from transformer for age of extinction. Flow chart. Okay, if we check the flow chart also, this is the flow chart where again what we have. This is the flow chart of ultrasonic sensor. So what we are doing, first we are reading a distance, taking a distance, the status of the distance on a variable distance from the ultrasonic sensor. Then we have put a condition, distance. If it is true, we'll do this. If it is false, we'll do this. Then we have another condition, another condition, another condition, another condition. And what are those conditions? Greater than 20, greater than 30, 40, up to 100. And if any of the condition will get satisfied, we'll be doing a task. What is our task? To glow that particular LED which we have assigned for that distance. So as in the first case, we are glowing first LED, then second, then third, then fourth, and like this we are glowing all the LEDs one by one. So this is the flow chart which we have made for this particular project. Okay. Now, in our previous session, I told you one thing, and that was binary numbers. What is binary number? So binary number, as we discussed in our previous session, is nothing but two logic levels or two voltage levels which is used in computers. Computer operates on two levels, 0 volts and 5 volt. In most of the cases, in some cases it may be 3.5 volt also. But let's say one standard assumption that the computers, all the computers use on 0 and 5 volt, and 0 is used to there is a name given it, a 0, binary 0, and 1 is binary 1. So binary theory or binary number is one separate mathematics theory. There were scientists who have devised this theory, which we sometimes say binary theory or binary arithmetic. And Boolean was a scientist who has even different theories. So I'm not going to discuss all those theories at this particular moment, in this particular at this particular age for you, because it will be confusing. But think it in this way, that if it is 0 volt, we'll say it is binary 0, and if it is 1, we'll say it binary 1 or logic 1. Since there is only two conditions, on and off, true or false, 0 or 5 volts, so it is called as digital, because there are only two conditions. And I have shown you this graph in previous session also, where we have high and low. Let's say we are glowing LED high, LED is on, LED is off. As you are seeing in this diagram, LED is on and LED is off with an interval of 1 second. It can be 2 seconds, 3 or whatever. So binary is 2. So that's why it is also called as base 2 number, because there are only two types of numbers, 0 and 1. In our daily lives, in our daily calculations, we use decimal number. This 1, 2, 3, 0, 1, 2, 3 up to 9. What is this number? Decimal number, because it starts from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 10 different types of number. That's why decimal number are called as base 10. Anyway, now why I am telling you that what is binary and what is digital? Because they are interrelated. Then comes to square wave. What is square wave? A wave which is high and low with same interval. So as you are seeing, this square wave is there, which is 0 to 5 volt, then 5 to 0 volt, then again 5 volt, then 0 volt. So what is happening? A wave is changing its position from 0 to 5 volt with some interval. And this second is a DC signal, which is 5 volt continuously. It is not changing. Its amplitude or its level is 5 volt continuously. Now from here I am telling you pulse width modulation. When we were discussing in our previous session, that I told you that we have in our Arduino pins starting from 0 to 13 and pins 3, 5, 6, 9, 10 and 11. These pins can be used as analog output pins. Please mark this, that in Arduino Uno, pin number 3, 5, 6, 9, 10 and 11 can be used as analog output. That's why this mark, mark is there in front of all these pins. But how these pins are using analog output? Because they use pulse width modulation technique to achieve this analog output. What is pulse width? It may be a little bit difficult for you, because this is one engineering concept. Even those people get confused in this. So don't take it seriously, but try to understand it. Now, if a pulse, this square wave pulse is there, if we change the width of this high, that means, as you are seeing in the diagram, duty cycle. Duty cycle means the cycle by which the on and off is happening. If it is 25%, which means the signal is high, or for 5 volt for 25% of the time. Let's say the time of the pulse is 1 second high and 1 second low. So if it is 25%, then that means it will be high for 0.5 second only. For 1.5 second it will remain low, and for half second it will remain high. If duty cycle is 50%, then it means for 1 second it will remain high, for 1 second it will remain, sorry, if it is 1 second, for half second it will remain high, half second it will remain low. And if the duty cycle is 75%, then 0.75 second it will remain high, and 0.25 second it will remain low. So what is happening here? We are changing the width of the high. We are keeping high for 25%, 50%, 75%, or 100%. And by doing this, what we are doing? We are changing the voltage level. So what is happening, that this pulse width modulation technique is used by the controller to give analog output on all these pins. I request you, please don't go in depth of this topic, because you are a young student. You will understand all the things slowly, one by one. If you will take these things seriously at this point, you will get distracted from the main topic. But keep this in mind, that with the help of this pulse width modulation, with the help of this pulse width modulation, we can achieve our analog output with the help of in Arduino boards. I think you got the concept. Think it in this way: we are just increasing and decreasing the height of the pulse. This is binary. We'll send you this image for your understanding. Decimal 0 is represented by 0000, and 9 is represented by 10001. And binary, or you can say the bit size, defines your computer capability, data handling capability. When we purchase a computer, what we look, we want 64-bit computer. So what is those 64-bit? Binary bits. So take a look on this binary number also. We'll send this image to you. Then now moving to our another project. Moving to another project, because we are running out of time. Motor control. If you understand these binaries basic concept in school time only, it will definitely help you in your future studies, believe me. Now we have on our another project, we have a motor, and we need to control its direction of operation. So we have these two switches here, slide switch. If I switch the slide switch on this right side, my motor is running in clockwise direction. If I switch this another switch on another side, my motor is rotating in counterclockwise direction. So if you want to control your motor direction in forward and in reverse by manual method, by switches, you can use this circuit. So by the help of two slide switch, we can run a motor in forward and in reverse direction. So we have these two terminals of motor. This is one black and this is one red terminal. So if we power them with the battery, directly with the battery, motor will be rotating in any direction. When we reverse the position, the terminal, if we reverse the battery polarity to this motor, the motor will be running in different direction. But how to use them, or how to make them, how to rotate a motor in forward and reverse direction manually with the help of switch, then you need to use this circuit. We have used this. Now we'll move to one IC, L293D IC. So what is this IC, L239D IC? So this IC is there which is used to control motor. So whenever you have to control a DC motor with the help of your Arduino board, you need this driver IC, L293D driver IC. And why we need to use this driver IC? The reason is a motor operates, let's say, at 5 volt or 9 volt or 12 volt. So when motor will be running, it will be asking more and more current. So if we directly connect it with Arduino will not able to send that much or feed that much current to the motor, because the rating, the capacity of feeding the appliance of Arduino is very small. It cannot, we cannot load it with more and more devices. So whenever we have to drive bigger devices, let's say motors, and not the bigger devices, if we have so many devices connected with Arduino, then we need to check, then we need to feed all the devices separately. We need to power all the devices separately, otherwise what will happen? You may damage your Arduino board. So because of this reason, that we cannot feed our motor directly by the Arduino, although there is a pin, 5 volt pin and ground pin on Arduino, but in that case also, if it is having pin, but still we cannot power devices directly by Arduino. Why? Because it is not having that much power capacity or current capacity. So as you are seeing in the figure, we have this L293D driver IC, and what we are seeing here, this one motor is connected, these two pins, pin number 3 and pin number 6. So these two terminals will be connected. We need to connect these two terminals to pin number 3 and pin number 6, which is output pins. And when we need to operate this motor with the help of Arduino, we need to send the signal coming from the Arduino, from two pins to input 1 and input 2. So this driver IC can operate two motors at one time. So you can connect two motors with this driver IC, and you have two inputs, input 1 and input 2, which will be connected from Arduino pins. So Arduino output pins will be connected to these two input pins. Then since we need to drive this IC, so this power pin, which is pin number 16, will be connected to 5 volt DC. So this 5 volt DC will power this IC. But to drive the motor, we need to give separate power from separate power supply or from separate battery, which will be connected to pin number 8. So let's say we are using a battery of 12 volt or 9 volt. So that 9 volt battery will be connected to pin number 8. So what will happen then? The Arduino will be only sending the signal to operate the motor. It is not sending the power signal. So this pin number 12 will be connected to power pin. So in the same way you can connect another motor. So now moving to the project. In this project we have used simple motor. We are not using Arduino. But in place of Arduino pins, we are sending these two signals from these switches to control the motor in forward and reverse direction. Now moving to another project. Now we'll connect the motor with Arduino. So are you enjoying? I think this is a little bit difficult today. It's a little bit different and a little difficult also. Is it? But this will help you to interface your motors, because whenever you will be designing your robots or any car, you need to interface your motor with your Arduino. Then in that case you need to know all these concepts. Chenoe, okay. What about others? Dragon Seni, yes sir, very good. Unnati Agarwal, yes sir. A bit tough, yes, it will be, because the concepts are new and there are different things. But don't worry, we are here to help you. We are here to help you. Shabd Seni, yes, very good. Okay. You will understand everything when you will see it closely, and when you will practice and connect these circuits, you will definitely understand the concept. Parv Tyagi, yes sir, we are enjoying, very good, very good. I am impressed. It doesn't matter the number of people watching this video is less, but all are innovators, young innovators. Okay, I am here on my screen with a new project, Arduino, one DC motor, and it's connected with the help of L293 driver IC. So as I shown you in the diagram, what I have done, I have connected to pin number 1, which is the power pin, connected to 5 volt DC. Pin number 1 of L293, which is power pin, the power pin is connected to 5 volt, as I told you. So this 5 volt will be driving this IC. Then we have pin number, we have this pin number input 4, which is connected to Arduino pin number 4, and Arduino's pin number 5 is connected to pin input 3. So these two pins of Arduino will be used to drive the motor in forward and reverse. So let's say on pin number 3, pin number 4 it is 0, and pin number 5 it is 1. Motor is moving in forward direction. And if it is pin number 4 it is 1, and pin number 5 it is 0, motor will rotate in reverse direction. So by changing these two pins, 1 and 0 on these two pins, we will be managing, or we will be controlling the direction of rotation of the motor. Then we have this battery here, 9 volt battery. As I told you that we need to feed the IC with separate power, which is connected to power pin 2, and it is connected to 9 volt. So this motor is fed by this 9 volt with the help of this L293D. So now motor is not driving this motor. That means the potential, 5 volt potential, is not going to the motor. Which potential is going to the motor? 9 volt. Only thing is that we are only sending the signal from the Arduino. So what Arduino is doing? Arduino is asking motor, move forward direction, move reverse direction. It is not putting its power to drive the motor. Only thing is it's sending the signal. It is like this, that if I ask Sanket, run the motor in forward direction, run the motor in reverse direction. What I am doing, I am just sending the signal. I am not connected physically with Sanket. Only thing is that I am sending the signal. The same thing is happening here. Arduino is only sending the signal, asking the driver to control the motor in forward and reverse direction. Who is sending the power signal to motor? The L293D IC with the help of 9 volt separate battery. Then when we see the simulation here, if I check the simulation, you will see that we have two push buttons here, and these two push buttons will be sending the signal to pin number 2 and pin number 3. So these two pin number 2 and 3 will be sending the status. What we need to do, on one input we need to send one. When I press the first push button, my motor is driving in forward direction. That means if I press first button, I am sending high on pin number 2 and 0 on pin number 3. So motor is driving in forward direction. If I press, in clockwise direction, if I press second push button, I am sending 0 on pin number 2 and high or 1 on pin number 3. So now I have reversed the condition. So motor will move in reverse direction. So with the help of this Arduino, we are moving this or running this motor forward and reverse direction. Now we'll see the code. If I see the code, if we check the code, what we are doing, we are reading pin number 3. If it is high, set pin 5 high. That means out of the 2 output pins, what are 2 output pins? 4 and 5. At a time, one need to be high and automatically other will remain low. So we need to keep this combination, one high, another low. So the same thing we are doing here. When the digital pin 3, which is connected to a switch, when digital pin high, set pin number 5, which is output pin of Arduino high. So motor will be running in, let's say, in clockwise direction. Another condition, if set pin 5 low, if it is low, otherwise set the pin 5 low. So this is the condition. If pin 3 is high, make it high, otherwise keep it low. Another condition, if I press another push button, that means which is connected to pin number 2, if another push button is pressed, or we can say if it is high, then what we need to do, we'll set pin number 4 high. So what is happening, I'll show you in word. Which word? I'll show you the pattern here. So what is happening, we are only doing that. I'm showing you the word file. So what is happening here, we are giving 1 0 or 0 1 to the Arduino board, and in the same fashion Arduino is outputting 0 1 or 1 0 to driver IC. So what we are doing, we are inputting make it 36, we are inputting what, 0 1 or 1 or 1 0. So these are the two conditions which we are feeding with the help of our switches, 0 1 or 1 0. So motor, let's say in 0 1 it is moving clockwise, and in another condition, let's say the motor is moving counterclockwise, or it may be different. It depends on how you have connected or how you have programmed it. But there is one more condition, and that condition is 1 1. That means if we press both of the button, what will happen? If we go to these are two push buttons. If we one by one, if let's say I press this first button, motor is moving in clockwise, that means I'm sending 1 0. If I press second button, that means I'm sending 0 1, and motor is moving in counterclockwise. If I press both of the button, that means if I send 1 and 1, I'm saying 1 and 1, please don't get confused. You can also say 5 volt or 5 volt, or 5 volt or 0 volt, or 0 volt or 5 volt. 0 means logic 0, 5 volt means logic 1. So what will happen if I press both of the button? Write in the comment section. If we press both of the button at a time, let's say I have one button, another button, I'm pressing one button, motor is running in clockwise direction. I'm pressing another button, motor is running in anti-clockwise direction. If I press both of the button, then what will be the condition of motor? What will happen? I'm looking on your comments. What will happen if I press or if we press both of the button? Okay. Write in comment section what we should do. They will cancel each other's effect. Yes, King's Avatar, okay. Unnati, DC motor won't move. Very good. Sir, I think the motor will stop. Very good. Aruna Sharma. Very good, very good. Shenoy, it won't work. Yes. So this is up to you what you want to do. You can even make the motor dance forward, reverse. But in normal scenario we used to stop whenever those two buttons uh, pressed at a time. So I'll show you one more diagram, one more project where we have used slide switch, where we have used slide switch. Sorry, we have used slide switch. Where is it? Okay. I'm just showing the operation. I'm not going to show you that how it is going to work. We'll send you the task. Briefly, I'm just telling you about this project. What we have done here in this project, we have two slide switches. Again, we are using one motor with L293D, but apart from this, we have one potentiometer also. Last time we discussed, you should know about potentiometer. What is potentiometer? So as you are seeing, when I press this first switch button, motor is running in clockwise direction. If I press another button, motor will run in counter clockwise direction. But one more thing is here, we have used this potentiometer here. Why we have used this potentiometer here? So if you want to make your hand free, if you don't want to keep the button pressed, you can use the slide switches. Keep the slide position on any side in which you want to move the motor. And we can also use a potentiometer. So why we are using potentiometer here? This potentiometer is connected to analog input pin A0. So as we discussed, two of the pins of the potentiometer are connected to ground. This black wire and this red wire is connected to 5 volt. And this third pin is connected to A0 of Arduino. So why we have used this potentiometer here in this project? I am looking on your comments. Write it fast if you have any idea about this potentiometer, use of this potentiometer. As a resistor, Mariam, very good, very good. As a resistor, potentiometer is a variable resistor. We discussed potentiometer is a 3-terminal resistor sliding or rotating. Shenoy Maria, adjusted voltage divider, very good. That means we can send variable potential. So, Mariam, you are very close to the answer. I mean, you got the idea. In fan, GCM, GMAT. So we are using this potentiometer actually to give analog input. We need to give one variable value to the input. Why we are doing this? Whenever we need to run the motor or we need to vary the speed of a motor, we need to give analog signal. Let's say you have a fan and you want to adjust the speed with the help of a regulator or potentiometer. Then what we are doing actually, we are basically sending variable potential. So we are giving 0 volt, 1 volt, 2 volt, 3 volt, 5 volt. Let's say maximum is 5 volt. So what we are getting at analog input? We are getting variable potential or variable value. and based on that variable value, according to our program, what we are doing, we have divided the speed of our motor. Let's say if it is 1 volt, will run the motor at 20% speed. If it is 2 volt, 40%, 3 volt, 60%, 4 volt, 80%, 5 volt, 100%. So to vary or to change the speed or to run the speed motor at different speed, we need to have something to some input from at our analog input to run the speed at variable, to run the motor at variable speed. You can, without using this potentiometer also, you can run the motor at different speed. Then in that case you need to set the condition in your program. But if you need to control the motor externally, then potentiometer need to be used in your project. So apart from potentiometer, everything is same, which we have discussed in our previous example. Only thing is that one extra potentiometer is attached here to analog pin A0. Now we'll look to the program. As you're seeing on the program, we have added one extra condition, which is analog. So what we are doing, we are setting the pin 9, which is connected to pin 9, which is input pin of Arduino, output pin of Arduino, and we are reading the value of analog sensor from A0, and whatever be the value, it will be overlapped or it will be written on pin number 9. Now moving to our L239D, there is one more pin I didn't tell you before, which is an enable pin. As you see on the diagram, this is enable pin. So what this enable pin is doing, this enable pin is nothing but analog input pin of L293D. So we need to send the analog signal to this pin. So based on the analog signal, this IC, this driver IC will rotate the motor. So directly we cannot connect the motor with variable pin, variable analog output. So what we need to do, we need to send one analog output. Whatever analog input we are getting from the potentiometer, we need to send that analog output to this IC, which is for motor 1 analog pin 1, pin 1 of IC enable pin. And if you are also connecting with another motor 2, then you need to connect another analog output pin to pin number 9 enable 2. So what this is doing, this is nothing, again the same thing is here. Let's say I am sending variable signal. I am sending variable signal to Sanket or Rehan. I am sending that based on my voice intensity, increase the speed. Based on my arm level, raise the fan speed. So I am indicating to Rehan or Sanket that I am raising the arm. I am raising arm. So what this is doing? This is sending a signal, a variable signal. Let's say from this place to this place. If I am raising my hand, Rehan is increasing the fan speed. Again increasing the fan speed, and maximum speed. So I am sending analog signal. My analog signal is received by Sanket, and then Sanket is sending analog signal back to fan. So same thing is happening here. I am receiving analog signal from potentiometer. Then I am sending the same signal on pin number 9, which is connected to IC, and that IC is sending that analog signal to motor, or you can say that IC is controlling the motor speed based on analog signal sent by Arduino through pin number 9. Then we have set a condition, again the same condition which we have used in previous example, that if we slide or make pin number 3 high, motor should run in clockwise direction, and if we make pin number 2 high, motor should in counterclockwise direction. So these instructions will remain same. Only thing which we have changed here is the first block. This block is reading the analog signal from A node and sending or writing the analog value on pin number 9. So this pin number 9, as you are seeing in the diagram, this pin number 9 is connected to IC's enable pin. So this is how we control the motor speed with the help of Arduino. So Arduino has reduced the headache of controlling motor. So automatically you can control motor speed. This project will be helpful for you in designing a lot of projects, because there are a variety of projects in the market where we use motors, fans and different things to control it, to control the direction, to control the speed and many more. And this L293D IC is also one of the important IC which is used in DIY projects for different applications. Okay, is it clear to you all? Senoy Mariam, I am impressed. You are very active. Thank you. It is just controlling the path of current. Yeah, that's what we are doing actually. With the help of Arduino, we are controlling the potential of motor, varying the potential of the motor, changing the polarity of motor. Think it in this way: if I have a motor and I am manually changing the polarity of, I'm changing manually the terminal of motor. Let's say now I have connected positive to positive, negative to negative terminal of motor of the battery. Then again I have changed it. Then I have connected negative to positive, positive to negative. So that is the manual operation, manual controlling. What we'll do if we need to control the motor automatically? That's the condition where we have to use a controller. It doesn't mean that we need to use only Arduino. There are a variety of controllers in the market. You can use any of them. They will be working in a similar fashion. But because Arduino is very good for DIY and these prototyping applications, most of the time we use in DIY Arduino Uno only. I hope you got the idea. Okay. Now moving to another project, which I believe will be very exciting, again very exciting for you. This is a 7-segment display project. Have you seen 7-segment display? I'll show you in my PPT, in my slide. 7-segment display. Have you seen 7-segment display? To display numbers on station, there is a digital watch which is used to show time. Big displays are there on railway stations, hospitals, to show time, date and different things. So it is the same display, 7-segment display. Why we are saying it's 7-segment? Because we are having 7 LEDs fitted in a fashion to display our numbers, and they are marked as LED A, LED B, LED C, LED D, LED E, LED F. So let's say we want to display 0. So what we need to do? We need to turn on LED A, B, C, D, E, F. So except G, all the LEDs need to be turned on. So we can display numbers from 0 to 9. So in the same way, whatever numbers we have to display, we make a table. And as you are seeing in the table, this is digit 0, 1, 2 up to 9, and on the in front of it, it is a 7-bit code. And this 1 means 5 volt, 0 means 0 volt. That means if it is 1, LED will on, and if it is If it is 0, then LED is if it is 0, LED is off or 0 volt. So as we are seeing on the screen, we need to display 0, so we need to turn on LED A, B, C, D, E, F. Except G, all the LEDs will turn on to display a 0. Let's say we want to display 9. So what LEDs we need to display? Except E, all the LEDs will remain in on state, or we need to turn on all the LEDs except E. In the same way, if we want to display 3, so except except F and E, all the LEDs will remain in on state. So in the same way, before writing our program, what we do, we make a table. So we check which LED will glow, will make 1, 1, 1, 1, and which LED is 0 will make 0. In the same way, if we want to display 1, so only B and C, so only B and C will remain on, as you are seeing here, B and C will remain on, and all of the LEDs will remain in 0 state. So like this, we use this LED. So to execute this project, to make this project, what we have done, we have used pin number 2, 3, 4, 5, 6, 7 and 8 to connect these LEDs to Arduino. So moving to the project. So this pin number 2, 3, 4, 5, 6, 7 and 8, these are output digital pin. They will be sending 0 or 1 based on the condition. They will see this simulation here. So we have written a program which will be displaying or which will be running a counter starting from 0 to 9. So as you are seeing, 0, 1, 2, 3, 4, 5. So this display is showing us a digit on it based on the code. And internally we know what is happening. Internally what is happening? That if we need to display 0, so we need to make all the LEDs high. 2, 3, 2 is connected to A, B, C, D, E, F. Except G. So in the first block, in this first 7 blocks, we kept all the blocks high except this 8 block, which is connected to pin number 8. This is digital pin 8 connected to G pin. Then we will wait for 1 second. Then we need to display 1. As I told you, we will be only glowing B and C. You can see it in the figure. We will be glowing this B and C connected to pin number 3 and 4. And now you can check it in the program. So pin number 3 and 4 will be high, and all other output digital pins will remain in low state. Then we need to display 2. So we'll check the table for 2, which LED should be in on state and which LED should be in on off state. Then for 3, for 4. So based on the table we have made for LED, for this 7 segment LED, we will keep on programming, writing our commands. So this, although the code is lengthy, but nothing is there. We are repeating the same task. That means we are using these same 7 blocks with a delay of 1 second again and again to keep the LED on. If you see the text code may be a little bit confusing for you, but what we have done, first we have, as you are seeing, this pin mode. What we are doing, we are making this pin 2, 3, 4, 5, 6, 7, 8. We are setting these pins as digital output pins. Then in loop, we are writing pin number 2 high means we are making pin number 2 high, or logic 1 or 5 volt. Then again we are using the same instruction. Then I'm using the same instruction. So how many times we have written these instructions? 10 times. Because we need to run the counter, we need to display 0 to 9. So this is how we interface our LEDs. But this is not the right way to interface this 7-segment display. There are other ways also, where instead of using these 8 lines, we only need to we only need 3 lines. By the help of 3 output digital pin, we can use our 7-segment display. Even there are 7-segment displays which uses only 2 pins. Huh? Even by 1 pin also there is a LED. So, but it is not there on the simulation. Sorry, so we cannot discuss that. But there are possibilities by 1 pin, by 2 pins, by 3 pins, by 8 pins. There are varieties of ways. There are many ways by which we can interface our LEDs. How is it? Isn't it interesting? So that's Unnati Agarwal. Okay, where that dot? Okay. Unnati, this dot is also one LED. Let's say we want to display 8.8, 8 decimal 8. So we need a decimal point in between. So let's say we need 2 7-segment display, and we have to display 2.2 or 2.5. So in that case, we'll be using this dot. This is not the dot. This is actually the decimal point. Are you getting? So this dot is for indicating a decimal. 8.2, 8.1 or 1.2 or 1.5, whatever number decimal fraction number you want to display, you can display with the help of this 7-segment display. But there is a restriction that we can only display numbers and few of the alphabets. That means A to F we can display. But if you want to display complex symbols or any other alphabet, let's say Q or R, or we can say small alphabets, then that is not possible to display. In that case, we use 14-segment display, where we have 14 LEDs arranged in the display to display different numbers. Even dot matrix is there, where dots are there to display even images also, graphics also. Okay, so there are varieties of displays. There are OLEDs, there are LCD displays. Okay, now we are moving to our final project for today. But don't worry, we have practice projects for you. We'll be sending you on your WhatsApp numbers. We have practice circuits, practice projects for you. And one more announcement I would like to give you, to tell you here, that due to Diwali celebration, we have postponed next week's session. Now our 4th session will be going to conduct on most probably on 22nd of November. That means next to next Sunday we'll be having our 4th session, where we'll be discussing projects and where we will be allotting you projects for awards and training kits. So our next session, Rehan, is that next session will be on 22nd November. So next session will be 22nd November, and happy Diwali to all of you. Try to avoid crackers, because we all know global warming, we all know pollution level. Try to make it easy. Try to reduce the. I'll say that don't play crackers, don't use them. But if still, because you are kids, it's difficult. But if still you will be using, try to reduce them. The number of crackers you have used in your past. So happy Diwali once more in advance. Okay, now moving to the last project for today's session, and that is servo motor. Have you heard about servo motors? What is servo motor? What is the plus segment in the circle? Plus segment? King Avatar. Wait. Tinkercad. Let me check. Okay, this is servo. So what is servo? There are conditions or there are projects where we need to operate a motor or operate something at different angles. Let's say you want to make one door which opens at different angle. Let's say this is a door and you want to open at different angle. 30 degree, 40 degree, 45, 90 degree, sorry, 90 degree, 180 degree. And in the similar way, if you want to make a barrier which opens at different angle, let's say 30 degree, 90 degree, 180 degree, and there may be cases where you need to you need to point a light at different angles. So when there is a movement based on angle, that means when you are or when you need a fixed angle, you need to move or rotate a shaft at particular fixed angle. In that case, you need to have servo motor, because simple motors cannot be used in that particular fashion. Reason being their internal design. Doesn't matter if a motor is with gear or without gear, but it's difficult to maintain a fixed angle with simple motor, simple DC motor. You can approximate, you can run, you can change the motor shaft, simple DC motor shaft by different techniques. Let's say by giving a delay to change the shaft at somewhat 30 degree, but you cannot fix the angle in simple DC motors. So what is the solution? Solution is our servo motor. So what is servo motor? Servo motors rotate at different angle. As you are seeing on the screen, I am running a simulation. This motor is rotating from 0 to 360 degree, then again back to 0 degree. So this servo motors, mini servo motor comes in two varieties. One operates from 0 to 180 degree, and there is another servo motor which rotates from 0 to 360 degree, then back to 0. So now let's say you want to in this project we are simply rotating a motor based on the program. As you are seeing that we have used a counter where we are increasing the value by 10, by the 10 value starting from 0. That means motor will be rotating 10 degree, 10, 20, 30, 40, 50, 60 up to 360 degree. Then in the this second block, what is happening? That motor is running in the reverse direction, 360, 350, 340, 330, like this up to 0. So this is this count instruction is counting up, and this count instruction is counting down, and the count increment is not by 1. What is counting? 1, 2, 3, 4, 5, or 10, 20, 30, 40, or 100, 200, 400. So that is what the value, the variable value or fixed value you are giving in the increment of your count. So we are giving the value of 10. So this count is increasing on every cycle. It is increasing from 0 to 360 with an increment of 10 count. And you are seeing that pin 2, because this pin 2 is connected to Arduino, servo pin 2. So this servo is having 3 pins. This ground to apply 0 volt, this red to apply 5 volt, and this middle pin is to send the signal, the pulses. It will send the signal to servo motor to operate it at different angles. So there are ways internally. This Arduino board, they send signals to servo motor to operate it at different angle. We'll discuss it in when you will be attending our future videos, because right now you just keep this in mind that with the help of Arduino we are controlling our servo motor. So this pin 2 is connected to here. So this is a code. Here we are running this forward bias and in forward direction 0 to 360 degree, and then back to 0 degree. Okay. Now moving to a case. Let's say you want to control the shaft of servo motor with the help of potentiometer, then what we need to do? This is the project. This one. This one. So this project is there where we have used a potentiometer. But this potentiometer again will be giving one analog signal. So based on the analog signal, the shaft will be changing its angle. You can see here, I am changing this potentiometer. My angle, the servo angle is changing. And most of the time, this mini servo motor, they comes in the range of 0 to 180 degree. So what you are seeing here, that when I am changing the analog value at the input, my servo angle is changing. So like this you can do it. You can see the code here. What we have done here in the code is very simple. Whatever we are reading on pin A0, analog pin A0, we are sending it to pin number 2, and the range is 0 to 180 degree. That means we are operating this servo motor within a range of 0 to 180 degree. So what is happening here, that whatever value we are sensing or we are reading at analog pin A0, we are directly putting it on pin number 2, because pin number 2 is connected to servo motor signal pin. So this is how we control our servo motor. Check it once more. Check it once more. That with the help of analog input, we are controlling our servo angle. So this is how servo motor operates. So these are the main components: your motor, your ultrasonic sensors, your gas sensors, your potentiometer, your servo motors. These are the main sensors and actuators we have interfaced till now with our Arduino board. Doesn't matter whether you are using Arduino Uno, Arduino Nano, things will remain in the way of interfacing will remain same, the way of programming will remain same, and even if you are interfacing some another sensors, the way of interfacing sensors will remain same. Sensors will be having 2 points for powering it, one with ground, one with 5 volt, and there may be one output pin for digital or for analog. So the sensor may be digital type or maybe analog type. So as we are seeing this proximity, this ultrasonic sensor, this is digital sensor, analog sensor. Gas sensor is also analog sensor, but we can use gas sensor as digital also. So depending on the requirement, depending on the application, we use different sensors and their types. So we have covered all the projects here, and we have some more projects for you which will be sending to you by our team on your WhatsApp numbers. As you are seeing where we have connected 2 motors. This is one project where we have connected 2 motors, and there is a project where we have connected 2 motors with Arduino. Okay, by mistake I have deleted it. No problem. So we will be sending more projects to you for your practice in this week. We will be having 2 weeks gap. I request you to practice as much as possible, because this is what the beauty of Tinkercad. You don't have to worry about connections, connect them anyway. You don't have to think about the components, that whether they will damage or not. Connect them in any way. Connect motors, different motors are there, connect 7 segments, sensors and all, practice them. In meanwhile, in these 15 days gap, and we'll be working and non-working model. Please, whenever you send the images, please send them in the simulation only. Don't take the image. Take the image like this. As I have opened, this TechWool Technologies is written here, or try to make it like this, that open the circuit and take the image of this whole screen. Take the image of this whole screen. Then send it to us. And one more thing is there, I forgot to tell you. Please send the selfie. I request you please send the selfie with Tinkercad. Working on Tinkercad, please send your selfie to our official number +95 2000887. It will be so nice of you if you will send your selfies. That will motivate us seeing you working on live with this simulation. Please send your selfies. I am looking on your comments. If you have any query, please write into the comment section. We have finished our session. This is our query time. If you have any query, please ask. Microbit. This is one more module added by Tinkercad in this simulation. We'll discuss that too in next session. Don't worry. We'll discuss microbit too. Suraj Goswami, Shabd Saini, Shenoy or Mariam, Kings Avatar, please send us your beautiful selfie with Tinkercad working on any of the project, Arduino project. Shabd Saini, thanks a lot for your appreciation. We'll try our best to give. We'll deliver more content beautifully in coming session also. Thank you, Suraj Goswami. I'm looking on your comments. Thanks for joining us today also for this session. Okay. Shinoy Mariam, there can be query if we have a good tutor like this. Thanks a lot, Shinoy. Thanks for your kind words. Thank you. Thank you. Okay, then we are finishing our session here. See you in our next session and practice all the circuits. Thank you. Goodbye. Happy Diwali once more.